Good afternoon. So let us define the problem statement for this particular session as a band pass filter design using the sections of low pass filter and high pass filter. In the previous few lectures we have defined what is filter, what is low pass filter, what is high pass filter. Now we are moving one step ahead. So if the sections of low pass filter and high pass filter circuits are given, then how to construct a band pass filter? Okay, so if we redefine these three filters, first a low pass filter, high pass filter and band pass filter, their definitions are like this one. A low pass filter will transmit the frequencies up to a value say fH. If I use the notation fH as the higher cutoff frequency of low pass filter, its simple meaning is if I plot the frequency response of low pass filter, which is the graph of gain versus frequency or output voltage versus frequency, the nature of this graph is like this one, ideal graph. So here is the zero frequency, 0 hertz, and here is fH. Okay, so that means this range is transmitted by the circuit. And this range is nothing but the lower range. So here corresponding to this I am getting pass band. From FH onwards there is a stop band. Okay, so this is the definition of a low pass filter. Now if I define high pass filter with a cutoff frequency FL, its meaning is this circuit will transmit all higher frequencies above FL, where FL is the lower cutoff frequency of high pass filter. So once again, if we plot the ideal frequency response, so the nature of that response is like this one. If say FL point is here, then between 0 to FL there should not be transmission. So corresponding to that you will get the stop band. And from frequencies FL onwards, the circuit should transmit the signal. So corresponding to that, you have a pass band. Okay, so that is the meaning of high pass filter. Now, if I define the band pass filter, so this is the filter which transmits the frequencies between some range. Okay, that means if we plot the frequency response, then the range between two specific frequencies must be passed. Okay, that means corresponding to these frequencies there must be a pass band or a transmission band. So here I am getting the pass band. So if one frequency, if I write say here FL and if I write say here FH, this is the notation I am using. So circuit should provide two stop bands. So here is the stop band between the frequencies 0 to FL, and there is another stop band from FH onwards. So in between this one there should be a transmission. So a circuit which transmits some frequency range, desired frequency range, whereas attenuates other frequency ranges, that circuit is nothing but the band pass filter. And this is the ideal response. Practically if I draw the response of the band pass filter, then that response will be like this one. Initially there is attenuation. As frequency increases, then the circuit will transmit that range, and again there is attenuation band. So this is your nature, that is the V0 versus a frequency. So this is the maximum gain, VO max. So in order to calculate that pass band range, I will multiply this VO max by 0.707. So here is your VO max. So you will get the point somewhere here. And corresponding to these 2 points now, okay, so this gives us 1 point, this gives us another point. So if I write this to be say FH and this as FL, then FH minus FL is the pass band. So here is the pass band, whereas here you are getting the stop band. Now objective that we have placed for this particular session is using the sections of low pass and high pass filters. How to construct a band pass filter. That means whatever the low pass filter is there, this low pass filter is available. If I just assume like this one, this circuit is available, section is available. Similarly, the high pass filter section is available. So how to use these 2 sections so as to get the waveform, the frequency response of this type. So if we define low pass filter with cutoff frequency say FH and high pass filter with cutoff frequency FL, and if I connect these 2 sections one after the other, let me see if my connection is like this one, this is a common line. That means here in between these 2 points I will connect the input, a function generator, whereas here between these 2 points I will connect the load. Okay, so this circuit, first section, will transmit the frequencies up to FH. Okay, whereas this circuit will transmit the frequencies from FL, where FH and FL are the cutoff frequencies of low pass filter and high pass filter respectively. Now if you have 2 distinguished cases, if my case 1 is say FH less than FL, the frequency FH, cutoff frequency, is less than FL. For example, just for simplicity, if I take FH equal to say 1 kilohertz and FL equal to say 2 kilohertz. Okay, so the first circuit, low pass filter, will transmit the frequencies between 0 to 1 kilohertz. That means if I draw here the frequency response, that ideal frequency response is like this one. This is the frequency, this is say output voltage, and there is a transmission between 0 to 1 kilohertz. Okay, that means this is your 1 kilohertz point. So this is your pass band. So this section is connected after low pass filter. Okay, that means for this particular high pass filter, Vin is not the input that is available, but output of low pass filter is the input for high pass filter. Now what is high pass filter? It will transmit the frequencies above 2 kilohertz. That means between 0 to 2 kilohertz there is rejection. Now if you check this output waveform from a low pass filter, this is input to the high pass filter. So maximum frequency that is available is 1 kilohertz. Okay, whereas the frequency from which transmission is there, that is 2 kilohertz. Straightway, if we take this equality, if the cutoff frequency of low pass filter is less than cutoff frequency of high pass filter, what it results is all reject filter. Why it is all reject filter? Because with these cutoff frequencies 1 kilohertz and 2 kilohertz, whatever your output voltage is there, all the time output voltage is 0 volt. Okay, so if I now check the another condition, if I use say case 2 like this one, in which FH is greater than FL, When the condition is FH less than FL, all the time my output is 0. That's why that filter is called as all reject. And there is no application of such a filter because it is rejecting everything. So if I change the condition now, if I use say 5 kilohertz as FH and say 2 kilohertz as FL. So what will happen now? Cutoff frequency of low pass filter is 5 kilohertz. So if I draw the waveform at this point, now waveform or the frequency response there. So here up to 5 kilohertz. So here point is 5 kilohertz and this is your FH. Up to 5 kilohertz there is a transmission. Okay, that means whatever the wave is there, whatever the output is there, that is between 0 to 5 kilohertz. So this results to a pass band. Whereas above 5 kilohertz there is a stop band, no signal is available there. Okay, so output of this low pass filter is now input to the high pass filter, which is having the cutoff frequency 2 kilohertz. So simple meaning is whatever this signal is there up to 5 kilohertz, this is input to the high pass filter, and high pass filter will transmit from 2 kilohertz onwards. But the maximum frequency that is available is 5 kilohertz. So now if I check the frequency response at the output terminals, then that response comes to be like this one. Okay, so the high pass filter will transmits the frequencies from 2 kilohertz onwards. So if I take this point as 2 kilohertz, then your response is it will transmit the frequencies from 2 kilohertz onwards. But whatever the maximum frequency that is available is nothing but 5 kilohertz. So there is no issue of transmitting the frequencies above 5 kilohertz. Okay, that means if the 5 kilohertz point is here, then high pass filter will transmit up to 5 kilohertz. And hereafter, now since the input is not available, what are the output voltage is there? That voltage is 0. Okay, so this is your 2 kilohertz point, this is 5 kilohertz, corresponding to that you will get a pass band, whereas here you will get a stop band. Here also you will get stop band. So get the point. So whatever our objective was there, using the sections of low pass filter and high pass filter, I have to construct a band pass. So what I have to do is, this low pass filter I have to cascade with high pass filter. So these two values are just for example. You can adjust any frequency. So if I design a low pass filter and high pass filter with appropriate cutoff frequencies, that means the cutoff frequency of a low pass filter, if it is greater than cutoff frequency of a low pass filter, very surely you can construct a band pass filter. And already we have designed these individual sections. For example, what is the circuit diagram is there? That circuit diagram is a low pass filter followed by high pass filter. So if you work with the T section, your T section filter is like this way. So this value is L by 2, this is L by 2, whereas this is C. And the value of L and C are given by some formulas. So it is Rk by pi Fc, whereas C is 1 by pi Fc Rk. So how much is your Fc? Actually it is Fh. That Fh I have to use here. So based on that I can calculate L and C value. I can construct a T section a low pass filter. So this is T section low pass filter. Now this section, this filter is followed by high pass filter there. Okay, so high pass filter consists of capacitor as the series arm and inductor as the shunt arm. So this value is now 2C and L. So this is your T section high pass filter with a value of L and C given by Rk by 4 pi Fc, whereas here it is equal to 1 by 4 pi Fc Rk. Now this Fc is nothing but your FL. The notation we have used as FH and FL. So knowing the value of Fc, knowing the value of design impedance, you can calculate the values of L and C. Okay, that means if the problem statement is construct a band pass filter with band pass frequencies between 1 kHz to 5 kHz. If I want to design a band pass filter using the sections of low pass and high pass filter for a pass band frequencies between 1 kHz to 5 kHz, what how to do? How to design low pass and high pass separately. For this particular section, low pass filter, how to select cutoff frequency 5 kHz. Whereas for constructing this high pass filter, how to select cutoff frequency 1 kHz. Only the practical difficulty is when we are cascading these sections one after the other, there is a possibility of a loading effect. Okay, so that's why practically we have to insert some buffer here, so that whatever the required characteristics are there, you can get those required characteristics. Okay, so whatever the design is there, this design fall under wide band pass filter. So if the pass band frequencies are on a higher side, whatever the circuit is there, that circuitry is called as wide band pass filter, which can be constructed using the sections of low pass and high pass filter. In the next lecture, we will design a band pass filter using single network, single circuit, that is either a T network or pi network. Thank you.